Hello everyone, today I will show you how to design circular column in CSiCol column 10. Now let's start. After you open software CSiCol column, you can start from wizard, quick wizard, design, import, or start from blank, no section. You have to create new section by draw new section in the blank page and rectangular section. As the previous tutorial about rectangular section, you can check in my YouTube channel. And for the circular section, now we have to start from here. For the circular, click on circular section. After you click on this type of section, the default section is here. Now we want to correct this section and rebar. Let's start from the material. Click on this icon, and now you have to create new material. This is a default material in this software. Also, this is a default material for rebar, and this is a default material for steel. If you want to import other material, you have to click on the icon. And for the concrete, I select library from Europe, C certified cylinder, add, and I add new other rebar material, rebar library I take from China. It is available in my zone. Now we have to select HOB 400, and if your zone uses 500 megapascal, you can select here. Okay, add. Now we finish define material, import material, close. You check here, default material, and this one new concrete material, and this one new rebar material. Now we have to select on the shape. You see here, shape, name. You can type name what you want. Circular column 1. Okay. Material, you select your material, and stress strain curve. No, I want to change radius. Okay, or dimension. Default dimension of this circular column is radius 400. Now I want to decrease to 300. Okay, enter. You can see the section after we complete the outer radius, but the rebar is outside of this section. Now we have to correct this rebar. Come back to rebar pattern, select on rebar CSiCol 1. You see here the radius. I want to take radius also 300. Okay, and the clear cover, the cover from the outside of section to the main rebar 40 millimeter, and the circular, okay, about the number of rebar in this section is 8. Now if I want decrease to 7, you can change it, or to 10, you can change it. But for the circular section, in the code recommend you 4 rebar diameter, as you can possible use in this section the minimum section, so you have to use 8 rebar. Okay, 8 rebar in one circular section for the supporting member. Now I have to select bar diameter. Okay, the minimum clear spacing from one rebar to other rebar, and right here we correct already. In the position we have to put in the original position 0 0 and angle 0. Okay, now we have to continue to other step about loading combination 1. You can create combination 1 shall load, okay, 400 tons or 4000 kilonewton. Moment about top, moment about bottom, moment, oh no, sorry, no moment about top edge, top y, okay, top edge from here, and top y from here, and moment at the bottom edge, bottom y. Okay, now we have to check about the load combination 1. It is the load combination, is not a load combination. You input the results that you combine your load and input the total value in here. Okay, close. About the slenderness, as I explained you previous tutorial about how to design CSi column correctly, you can check more detail at here. So is our column is a long column or slender column. We have to include the slenderness effect in this column. It is short column. We do not include the slenderness effect in this column. Okay. Now about frame condition, you have to assign the frame condition. What the condition you want to assign, which pin, which ruler, which free, and the frame general. Now I want to select which. For the previous tutorial I had to select and frame general cast. Now I had to select which at top and which at bottom. Okay, you see here the length of the column is 3.5 meters. As my purpose, I want to design it as the slender or the slender column. Now we have to correct the unsupported length. Okay, now you can increase the total length to 5 meters. Okay, 5 meters, and unsupported length from the top of the slab to the bottom of the beam, also the 4.5. Okay, 4.5. Okay, consider non-folding column. Okay, now you see here we have input the length and unsupported length. Okay, correct. You see it has two XZ and YZ. You can view in the 3D here. Our column work in 3D, so we have to input information for both direction and in both length. Now we input in one plane. We have to input in another plane. Okay, it's the same. Okay, it's the same. XZ and YZ. Okay, compute. Now we have to check again and combination about consider sway. After you analysis in a 3D model, by using a tape, SAP, or other software like a robot or like a global FM. This is good. You can check about the critical alpha critical. It is greater than 10. It column we can consider as a non-sway or break column, but it's the critical alpha below than 10, so the column will be designed as a sway column. And for the tape and SAP, you can use the moment, second order moment compared with the first order moment. For zero code is greater than 10, we consider the column as a sway column. And for the CSiCol is the second order moment affect divide on the first moment or the effect less than 5%, we have to consider it is non-sway. Is greater than 5%, we consider the column is sway column. So the consideration sway and non-sway, you have to check it first in the 3D model. It is very important. Now we have to consider only the slenderness. So for the long column, we must to include it slenderness. Okay, it affect in column because it long. So we have affect the slenderness. But the considered sway is the other criteria we have to check in the 3D model about the global effect. Okay, you can check the displacement, you can check the comparison of the moment second order effect or the further effect, or you can use other method is use the critical moment in the critical load factor in the global FM, or in the Tesla structural designer also has this option to check. So now we let to continue to design. Okay, we have to select on the result. You can check the section property you apply, it's right or not, section stress, interaction diagram. You can check here. This is the angle, so we have to check the local combination directly at the top. And you see here the combination one is out of the resistance or the cross section, so you can check on the other one combination at the bottom of column. At the bottom is okay, but at the top is not okay. So our result is not suitable. Now we have to check quickly the capacity. Okay, straight in the concrete, you can check. But now I want to check the summary report. The design ratio is over is 1.71%. 1.71 is mean is over about 71% from the capacity. So in this case, we have to increase the strength of concrete, or we have to increase the section. Now we come back to the concrete, and you should check again about the concrete. Okay, it's 75. Now I want to increase to 40. Okay, or increase to 45. Let's check again about the material. Select the icon, import new material, concrete, Europe. Okay, I want to increase to this one. Okay, now we have to check on the column. Okay, this one. And now you have to check again about the column summary. It's still over 14%. Now I want to increase diameter of rebar. You have to check on the circular one, and clear diameter is 40, is correct. The circular 10. Now you can increase from 10 to 12. Okay, to 12, and check the column is still over 10%. Now I have to increase from D20 to D25. Okay, let's check again. Now the capacity is 1. Okay, 1 is mean 100%, and the rebar ratio is 2.09%. It is acceptable for the combination bond. Okay, now I want to use D28 to D28, so this section will be passed. Now let's check quickly. Okay, the design capacity ratio is 94%. It's good. And column 1, combination 1, 12 dB. Okay, 12 rebar, diameter 28. Okay, now we have to spot check from the section property again. Energy rebar ratio is 2.61%. It's good for the for the construction side. And section stress, you have to check it here. Stress. Okay, interaction diagram, you can check it again at the top. Okay, it passed. Okay, design point detail, you can check from here. Material design load, here the design capacity of this section. Design moment 762.91 is the design capacity of this section. And the actual load ED, we apply the actual load 400 tons, and apply the moment at the top, the moment at the top other direction. So our section is says you can check along H and along Y, but it's not different because we apply the same moment and same force, and our cross section is circular. Okay, now close. You can check about DC capacity ratio. Okay, the remark is okay. Maximum capacity ratio 0.94. okay, you can check here, and you can export here if you want to export to Excel, and you can copy and paste to Excel. Okay, close. The detailed result. Okay, you can check here the detailed result. Combination 1, the moment vector, the actual compression, axial tension 0. We has not applied axial tension. We apply only the compression force with the moment applied at the top and bottom. And here the design ratio, and the design report you have. You can output two way. In the first way is simple report, a quick and summary report. For the detailed report, you can check it here. Now I have to select the simple report. You can edit the summary report, the section and the code, the shape, consider slenderness, yes, and strength, material, name, Okay, everything here, the concrete strength, elastic modulus, compressive strength for the cylinder, and the rebar name. Now you have to minimum 10 stress. Okay, here now you have to check about the detail report. I think this report is not fit with our purpose, because the rebar is a default rebar. Now I have to change it to my import material. You can see here it is our import material for the rebar. Now I have to change for the rebar again. Sorry for the default rebar. Now select from here and start again to summarize report. Okay, it's 0.84, only 84%. Okay, you can check on the detail report. It is the radius or dissection, the bridging name, the description for the material, concrete material. We use the concrete 40 megapascal cylinder, and we use the rebar strength 400. The minimum yield is 400 megapascal. And concrete, you can check here. Steel, we do not use steel, we use the rebar. In the rebar section, you can check here. The section says circular column and the rebar ratio. Okay, 12 rebar diameter 28 millimeter. It is the section property. You can check the section property in this part. The framing, top, and the total length, and the unsupported length. It is the bottom. Okay, and the axial edge you can check also. Everything in the important part you can check in this part. The moment, magnification, calculation based on the code, you can check on here. So our finally design result is 0.84. Thank you for your watching. I hope you can design column as you want in this software. Is very good, but you have to consider and check about some important point about slenderness, about the sway, non-sway column, and the design report compare with your Excel or your manual. I think it's acceptable when we compare with the design manual and other software. Thank you for your watching. Thank you.